The problems that we're going to call permutations, and I'll show you a nifty way to do them on our calculators. So, Venn diagrams, if you remember from like social studies or something like that, are the graphic organizers that have the circles on them. So like one example of a Venn diagram might be like the two circles that kind of overlap like that. You know what I'm talking about? Where this is something that happens here, and this is something that happens there, and this is something that happens in both of the options. Sometimes, probably at some point, you even saw Venn diagrams that had like 3 overlapping circles. So this part went to both of those, and this went to both of those, but this little bit in the middle right there was in all 3 of the circles. Well, we can use the same sort of Venn diagrams in math, and especially in probability, to try to keep track of some of our information. So, I'm going to give you an example. I just want to find one that I like better than that one. Alright, so here's a nice example. It says, there are 100 students in the 12th grade. 70 of them are enrolled in a math class. 50 of them, are enrolled in science. 10 of them are enrolled in neither, and 30 are enrolled in both. So, they want us to make a Venn diagram. Our Venn diagram's got 100 total students. So we're going to make a Venn diagram where we're going to total 100. 70 of them are in math. 50 of them are in science. 30 of them are in both. And 10 of them are in neither. So if we added all those up, do we have 100 kids? No. We have more than 100 kids because the math and science numbers include the 30 that are in both. Does that make sense? Okay. So, that's why when I looked at those numbers and added them up, 70 plus 50 is 120. I'm already off. Okay? And then if I had 30 and 10, I'm still way off. So, what we want to do is make ourselves a little Venn diagram. So we're going to start with our box. And on our test, you're going to already have the Venn diagram made, and you just have to be able to read it. So that's good news. So we're going to start with our box. And we need to be able to fit in all of our kids into the box. Alright? Well, if we have 70 kids that are in math, I'm going to draw my math circle over here. Math. And that number includes the ones that are in math and science. That was interesting.
Science.
Science backwards because it got too big for my space. There's 30 in this bubble, right, that are in both. So 30 kids are in both math and science. If there are 70 total kids in math, and 30 of them fit into this part of the circle, how many of them fit left over in this rest of the circle?
40.
40. So there are 40 kids who are just math, plus the 30 kids who are math and science to total my whole 70 kids that are in math. So that takes care of my whole 70 kids that are in math. And there's 50 kids that are in science, and 30 of them are in this circle, so how many does that leave to be out here? 20. So if I covered that up, this whole circle, that's all of my science, is 50, so that takes care of that. Have I already counted for my 30 that are in both?
Mm-hmm.
Mm-hmm. And then what we do in math with the 10 that are in neither are put them out here in the box. Yeah. We're not going to make a 3 circle because the neithers don't connect with them at all. Sometimes you can just like draw a little circle off by itself.
Yeah, that's what I did. I put
Yeah.
Its own island.
But in math, we usually just put it out there on the side. So then they might ask you, what is the probability that if we chose a student at random, that random student would be in a math class? So given the picture that we have in front of us now, what would the probability be that student would be in a math class? Well, what's the probability that they're falling in this circle?
Only math or math?
Right
In
now,
gen-
in math in general.
Okay.
Are you in math at all? If I was in math at all, I would take my whole math bubble, 70, remember our theoretical probability, how many there were available out of, how many total kids do we have? 100. So there's 70% chance that kid is in a math class. What is the chance that the child is in both math and science?
30%.
30%, or 30 out of 100. Sorry about that. What is the chance that they're only in science but not math? 20 out of 100, because we just look at the bubble part that's just the science. Questions about that we have at all? It is literally that easy. Nobody has any questions, concerns, comments? Alright, yeah.
Why do you add the 40 and the 30 but not the 20 and the 30?
This one, when we were up here, we said they're in math class. So these people were in math class and these people were in math class. Down here we said only science, not math. So these kids in the middle were in both. So we're not going to include them.
Oh,
We have 50% of the kids who are in science in general, but only 20% of them who are only in science and not in math. Okay? Oh, that was this guy down here, I guess.
The middle one was, we said, in math and science.
Yeah.
And what's the chance that they're in neither? 10%.
And that worked out nicely because it was out of 100 kids. If it was out of 200 kids, your number on the bottom would just be 200 we divide. Other questions, comments, thoughts, concerns? All right, let's switch.